All right, so the ACT expects you to have a very, very basic knowledge of the graphs of sine and cosine. And luckily, your calculator will graph these, but you have to have the mode in radians most of the time. If it's asking for, if the answers have pi in them, that's going to be radians. If it's a degree answer, then the mode should be in degrees. But if your calculator is not in radians, it can't help you for the most part. So that's a very important piece. All right, if we look at these graphs here, you'll notice that they kind of look like waves. Sine and cosine look very, very similar. The only difference is one is kind of shifted. You'll notice that cosine, the green wave, has a point at 0, 1 on the graph here, and the sine has a point at 0, 0, and then it starts to go up and then down and then up. One thing that you should know, one of the things you should know, is what a cycle is. A cycle is going to be essentially a piece of the graph that is copied over and over again. So for example, one cycle of the sine graph would be from this point and then up, down, up to this point. If I were to take a picture of this and paste it over and over again, I would get the sine graph, because this continues to go up, down, forever and ever and ever. So one cycle of this graph is from 0 to 2 pi, and this is just a basic sine graph. That is called the period. So the period, and I'll show you another example in a minute. A period is in this case from 0 to 2 pi radians. And we'll see what happens as we change the graph. Same idea with cosine. If we were to put our point up here, it goes down, up, and then right here, if we were to copy that over and over again, this would go down, up, etc. It would continue forever. Sorry, my drawing over here is pretty bad. But one cycle, again, is from 0 to 2 pi, so the period is from 0 to 2 pi. So a period is the horizontal distance of one cycle. So the horizontal distance of one cycle. As you change the graph that you're looking at, you also change the graph. If you have, right down here, if you have a graph and you put different numbers for A and B, A is the amplitude. Now the amplitude is half of the range, and the range is from the very highest point to the very lowest point. So for 3 sine of x, our range would be from -3 to 3, so this would have a range of 6, and the amplitude is half of that. So the amplitude, whoops, would equal 3. So the amplitude is from here to here. That is our amplitude. If we look at the amplitude of a regular sine graph, our amplitude is just 1. Because if you think about it, x by itself would kind of have a b value of 1. So if we had, let's say, y equals sine of 10x, that would be a really, really tall sine that would go from -5 to +5. Our range would be I apologize, I did something wrong here. I meant to put the 10 in a different spot. 10 sine of x. Sorry about that. Our range here is going to be 20, because it's going to be 10 up, 10 down, and our amplitude would be 10. Okay, so that's an example of that. Now the period is changed when you change b. B is the number of cycles completed from 0 to 2 pi, or 0 to 360 degrees. So 0 to 2 pi, that's here to here. If we look at our regular sine graph, and that's this one right here, if you follow this line, if we look from 0 to 2 pi, it completes one cycle. So the period there would be 0 to 2 pi, and it completes one cycle. If we increase this number to 2, you'll notice that it kind of scrunches up, and it completes two cycles. One cycle would be from here to here, another would be right there. So we have two cycles completed, and our period in this case would be 0 to pi, the length of one cycle. So that would be the period, 0 to pi. And then finally, if we have sine of x over 2, that is this one, we actually only complete half of a cycle right here, because you'll notice that this is not a copy of this part. So we only complete half a cycle with sine of x over 2. And so that shows you what the period is. So essentially what you need to know is that A gives you the amplitude, whatever that number is the amplitude. B is the number of cycles completed in 0 to 2 pi, or 0 to 360 degrees. And then the range is double the amplitude. That's essentially what you need to know. Otherwise, you can create graphs in your calculator, but make sure the mode is in radians.